we have a regular hexagon, and we're told that each side is 3.6 centimeters long, okay, but that is only to the nearest millimeter. Now, a millimeter is a tenth of a centimeter, so this time it's correct to the nearest 0.1 centimeters, which means in order to find the upper and lower bounds, we add and subtract half of 0.1, which is 0.05 centimeters. So the upper and lower bounds, well, we only actually want the upper bound for the perimeter, which is going to come from the maximum side length. So the upper bound for each side is going to be 3.65 centimeters, so 3.6 plus 0.05. And if we want to find the largest possible perimeter, well, a hexagon has got 6 sides, so we're going to need 6 of those, 6 times 3.65, and that comes out as 21.9 centimeters. Right, for the next bit, it helps to just think about a rectangle. We've got the area, we're told, is 80 centimeters squared. The length is 12 centimeters, and we're asked to find the width. Now, we know that length times width is equal to area. So if we're asked to find the width is going to be the area divided by the length. So I need to first of all work out the upper and lower bounds for the area. Now this area, 80 square centimeters, is correct to one significant figure. Now one significant figure means if I count from the beginning of the number 1, 2, so the first significant figure is in this column. Now this is the tens column, that 8 means 8 tens. So this 80 has been rounded to the nearest 10. Which means to find the upper and lower bounds, I'm going to add and subtract half of 10, which is 5 centimeters squared. Now that tells me that the area is between, so the maximum would be 85 centimeters squared, and the minimum would be 75 centimeters squared. Okay, if we now look at the length is measured to 2 significant figures. Now if you've got a length of 12 and it's measured to 2 significant figures, I'm going to count 1, 2. The second significant figure is this 2 here, which is in the units or ones column. So in this case, the length has been rounded to the nearest 1 centimeter, which means to find the upper and lower bounds, I add and subtract half of 1, which is 0.5 centimeters. So if it's given as 12, the maximum length is 12.5 centimeters, and the minimum must be 11.5 centimeters. Now, if I want to find the lower bound for the width, I want to find the smallest width, or the minimum width. Now, to find width, I'm going to have to do, as I've set up here, area divided by length, but I need to be careful as to which one I use. Okay, to find the minimum possible value when you're dividing something, I'm going to need to use the minimum area, and I'm going to have to divide by, to get the smallest number, I'm going to have to divide by the maximum length. So the minimum area is 75 square centimeters. The maximum length, which is going to give me the smallest possible width, the maximum length is 12.5. Now if I do 7.5 divided by 12.5, I get 6 centimeters. So the lower bound for the width is 6 centimeters.